So I want to integrate this, and remember the guidelines were to make dv the more complicated part, or we want to make u something that can be integrated until it gets something less. But really, when we look at this, we don't have that in either case. What I want to do is I want to call dv e to the x dx, and then I'll call u cosine 2x. So now I have to take the derivative and the integral and see what I get. So if I integrate dv, I get v is e to the x, and if I take the derivative of u, du is 2 sine 2x negative dx. So now I know I have my original. I'm going to write this because you'll see why. E to the x cosine 2x dx equals uv, so e to the x cosine 2x minus the integral of v du. So there's actually a plus here, 2, and I have e to the x sine 2x dx. So what I need to do now is I need to integrate by parts again. So I'm going to find a dv and a u, and then I'm going to see what I can do with it. So I'm going to go in the same vein. I'm going to call dv e to the x dx, and I'm going to call u sine 2x, and now I want to find out what v and du are. Well, v is e to the x, and du is 2 cosine 2x dx. So now I know that this part is, I have to look at the whole thing. So I have e to the x cosine 2x dx equals e to the x cosine 2x plus 2 times uv e to the x sine 2x minus v du. E to the x, 2 here, cosine 2x dx. Okay, so now look what I have here. I have this integral on both sides. So first I'm going to expand, so I have 2 e to the x sine 2x minus 4 e to the x cosine 2x dx. Here's what I'm going to do. I'm going to bring this one over. I'm going to add this to both sides so that I have here 5, the integral of e to the x cosine 2x dx, since these were the same. And it equals e to the x cosine 2x plus 2 e to the x sine 2x. We'll get that to that c in a minute. But now I got to get rid of the 5. So what I found was sometimes I can play around like this. I got the integral e to the x cosine 2x dx, which is what I wanted, is e to the x cosine 2x plus 2 e to the x sine 2x all over 5 plus some constant.